In section 5.2, we continue to look at slope-intercept form from a little different angle here. We're going to be writing equations of lines in slope-intercept form, but we're not going to be given all the information that we'd like to have, so we're going to have to take a few steps here. First of all, we need to identify the slope m, and then we'll find the y-intercept, and once we know those two pieces of information, then it's pretty straightforward to write our equation in slope-intercept form. But notice that these two steps kind of go hand in hand to some extent. If we know the slope, we can substitute the slope into our equation, and then very often what we're going to have to do will be to use the x and y coordinates of a point on our line in order to determine the y-intercept. So let's look at an example, a few examples actually, of how this works. So write an equation of the line that passes through the point -1, 1 and has a slope of 4. So we know our equation is going to look something like this. Y equals 4x plus b. To determine b, we need to use values of x and y from a point that's on that line. And sure enough, we're given the coordinates of one point on that line. So we substitute 1 in place of y. So 1 is equal to, and then -1 in place of x, and we still have plus b. So we have 1 equals 4 times -1 is -4 plus b. And then to move the -4 to the other side, we're going to add 4. And we end up with 5 equals b. So now we can write the equation y equals 4x plus 5. Alright, and number 2, write an equation of the line that passes through the points -4, 1 and 2, 13. Here we don't know the slope, so we're going to have to calculate it. So I'm going to take 13 minus 1 in the numerator. And then remember, because I started with 13 here, I have to start with 2 for the x coordinates. So 2 minus -4. So we have 13 minus 1 is 12. 2 minus -4 is 6, and that simplifies to 2. So we're going to have an equation that looks like y equals 2x and then plus our y-intercept. Now we get to choose, and we can use either one of these 2 points. So let's say we want to use -4 for x and 1 for y. So we have 1 equals 2 times -4 plus b. And that means 1 is equal to -8 plus b. And we'll move the -8 by adding 8. So we end up with 9. Oops, that's a 9 equals b. So then we have our equation y equals 2x plus 9. And notice that we should be able to use that equation for the other point, the point that we didn't use the values of x and y for. So if we take 2 times 2, that's 4, plus 9 gives us 13. So that checks out. Okay, number 3, write an equation for the linear function f with the given values. F of 0 equals 3, and f of 2 is equal to -5. Remember, f of 0 is the same thing as the value of y when x is equal to 0. So if you want, you can make a little table of f and f of x, or sorry, x and f of x. When x is 0, f of x is 3, and when x is 2, f of x is -5. So we can find our slope by taking the difference in the y values, -5 minus 3, over the difference in the x values, 2 minus 0. So that's equal to -8 over 2, or in other words, -4. So we know we're going to have y equals, or actually I should say f of x. Let me write f of x equals y equals -4x plus b. And I'm going to go ahead and use the point 0, 3 here. So we have f of x is equal to 3 and that's equal to negative 4 times the value of x is 0 plus b. But that means, remember, negative 4 times 0 is just 0, so we already know the value of b. 3 is equal to b. And so we end up with f of x is equal to negative 4x plus 3. And notice that when x is 0, we already actually have our y-intercept right there. So we really didn't need to go through all of this work if we spotted that. Our y-intercept is staring at us right there. Okay, number 4, the H2O company has noticed that when it prices its deluxe water bottles at $8 each, it sells $2,800 per month. And when they raise the price to $10 each, the sales go down to $2,200 per month. If, and this is a huge if, but if the relationship between price and sales is linear, predict the monthly sales if the price is set at $14. So if we want to look at, let's say, price and then the quantity sold. We know that when the price is $8, the company sells $2,800 per month. When the price is at $10, sales go down to $2,200 per month. And we want to calculate what happens when the price is $14. So we can use these 2 points, 8, $2,800 and 10, $2,200, to calculate a line or an equation for this line, since we're modeling it as a linear relationship. So for the slope, look at the change in the quantity. So we take 2,200 minus 2,800 over 10 minus 8. And that gives us negative 600 over 2, or negative 300. And what that tells us is for every dollar that the price goes up, the quantity will go down $300. So we could already calculate right here. If we raise the price $4 more, take 4 times negative 300 is negative 1,200. We're going to sell 1,200 fewer units. If we didn't spot that, then we would have something like this. Y equals negative 300x plus b, and then we want to calculate the y-intercept here. So if we use, let's say, that second point, 10, 2,200. 2,200 is equal to negative 300 times 10 plus b, or in other words, 2,200 is equal to negative 3,000 plus b, and then we would add 3,000 to each side to get 5,200 equal to b. So our equation is y equals negative 300x plus 5,200. And then we substitute 14 in place of x. So let me change colors here. So we have y is equal to negative 300 times 14 plus 5,200. And this is equal to negative 4,200 plus 5,200, which is, as we had already predicted, 1,000. So if the price goes up to $14 a bottle, we predict a sale of 1,000 units per month. Number 5, Mike belongs to a hiking club that charges a membership fee plus $10 per hike. After going on 5 hikes, he's paid a total of $95. So that gives us the coordinates of one of our points, 595. We know the slope right here, $10 per hike. So write an equation that gives the total cost as a function of the number of hikes he has joined, and then graph that equation. So we're looking for something like this. Cost is equal to, we already know our slope is 10, so 10 times the number of hikes plus the membership fee. I'm going to go ahead and call that b, because that's going to be our y-intercept. And we know the coordinates from one point here, so we know that 95 is the cost for 5 hikes, and we're trying to calculate the membership fee. So we have 95 is equal to 50 plus B. Subtract 50 from each side to get B. And we have 45 equal to B. So our equation is C equals 10H plus 45. $10 per hike plus that $45 membership fee. And then to graph this, we can look at the number of hikes. And then we're going to look at the total cost that he has to pay. This will be in dollars. And I'm going to go ahead and go by 20s. You could, if you want, put a little squiggle in the line here because you know there's no value below 45. That's where we start. Personally, I don't really like those little squiggles, and so I'm going to go by 20s. 180 and 200. Okay, so for 0 hikes, so as soon as you join, you have to pay $45. So that's the bad news, is going by intervals of 20, we have to judge where 45 would be. So somewhere around there. You go on 1 hike, you pay the $45 plus another $10 for that hike itself, so you're up to 55. And then we keep going by tens. So 55, and then 60, whoops, a little higher, 65, and then 75, and 85, and 95. There's the point that we already knew, 5 hikes, $95, 105, 115, get that up a little higher, 125, 135, and by the time you take 10 hikes, you're up to $145. Now, I would not connect these because we can go on 1 hike or 2 hikes, but nothing in between. You can't go on 1.5 hikes or 1.732 hikes or 1 1/4 hikes. Okay, so just go ahead and leave those points there. The key is that we found the membership fee. Okay, use the verbal statement below to complete the table, equation, and graph. The verbal statement is that Bob has $1, and each week he makes $2 for an allowance, and he's going to be saving that money, and we want to keep track of how much money he has. So here we're looking at time in weeks, and we want to keep track of the amount of money that he has, which is in dollars. And when he starts, he has $1, and then notice the time starts at 0. That's very common when we start with time. And then we're going to add $2 each week. So he goes 3, 5, 7. So the equation, well, we can look at the initial value is 1. That's what he starts with. The rate of change is 2 because he's saving $2 per week, earning and saving $2 per week. So our equation is y equals 2x plus 1. The rate of change times our input plus the initial value. And here we really only need the first quadrant here. So here we keep track of the number of weeks. So we start at 0, 1, 2, 3, etc. And we want to then keep track of the money that he has, which is in dollars. And I'm going to go by 2's here. 2, 4, 6, 8, etc. So at time 0 he has $1. After 1 week he's up to $3. 2 weeks he's up to $5. 3 weeks he's up to $7. And you could continue that pattern if you like. And again, I would not connect these points because he doesn't get paid after 1.5 weeks. He has $3 at the end of 1 week, and he has no more than that until all of a sudden, a week later, he's up to $5. Right, so there you go with some more examples of using slope-intercept form. As always, good luck.